Question 6. P Cubed uses GPS to track its delivery vans. Well, I think we can think about that as input and tracking its delivery vans. Programmers are working on algorithms to track the mileage of the delivery vans. Programmers are testing the algorithms with small data sets to determine if they will work efficiently with the very large data set. I think that's really important. Many of the answers that you gave talked about that the data set was really small and therefore it was easier, it would be better just for the human to do it, or it wasn't necessary for the computer to do it. And the key is that they're giving you just a small data set, but with the aim eventually that it would run with a large data set. So of course in an exam paper they're not going to be able to print out 15 pages just of numbers, which they would probably want to do in order for you to appreciate the scale of a search or a sort. They're only going to be able to give you a small data set. I think you just need to bear in mind that it's a sample, and the chances are that the algorithm that is would be running on much larger data sets. So it's highly unlikely that you're going to be talking about the length of the data set in the question in terms of the answer. Okay, I mean, I'm not saying it's not possible. Just be careful with that. Okay. Here is the pseudocode for an algorithm to find the number of mileages over 300. Okay, don't stop doing the highlighting. You might start really well, pay question 1, yep, there, and then it's almost becomes more important as you head into the paper and the harder questions. The clues are there, it's just let's find them. So we're talking about finding, so we're talking about search algorithms. Okay, it's almost guaranteed that you're going to get a question about searching or sorting or both, because that's part of the computational thinking spec, and I would expect them to examine you on one or more of our search or sort algorithms. Now we know 2 search algorithms. They are a linear search and they are a binary search. Okay, and if you've revised and you've revised well, then you'll have some ideas in your mind about those 2 different searches, when they're used, what their efficiency is, etc. Let's read the pseudocode. Set maximum to length mileage. Okay, so we've got a variable called maximum. It's going to be set to the length mileage. Set I to 0, set count to 0. So some variables being initialized to start with. While, so we've got a while loop. While I, currently 0, is less than the maximum, do the following. If, selection, mileage, I, so we've got an index position number. So mileage must be an array, because that would make sense here. The length of the list called mileage, and we've got a position number. So we must have a list, and actually if we look down here it does say stored in an array called mileage. If position number mileage is greater than the 300, then set count to count plus 1. End if, set I to I plus 1. End the while. So it's going to keep running as long as there are mileages stored in the list for it to check. Okay, and we've got a counter, because our task is to count the number of mileages over 300. So it's only going to set count to plus 1 when the mileage stored in the list is over 300. Okay, and then it's going to send the results. Mileage over 300, count would be a number, for example, maybe it would say 17. If it found 17 values, that would be our answer. Okay, so understand what your algorithm is showing you. Here is a small data set. It is stored in the array called mileage. Well, we've just discussed that makes sense. And here is our small array. Okay, describe one efficiency when executing the algorithm with this data set. Now it's a 2-mark question. We've got one inefficiency and we need to describe it, which means we need a 2-part answer. So a because, or this means that, or something like, it needs to be a linked 2-mark to a linked answer. So let's have a look at our array. It's an unsorted array, 2578213771087555308, and we are going to iterate, loop over it, all of it, because it stops when I is less than the maximum length. So length at the moment is 1, 2, 3, 4, 5, 6. So it'll run 6 times, because when I becomes 6, when I becomes 7, it would stop. So it's going to do the whole, it's going to go through the whole list. Now remember, this is a small data set, but we are expecting at some point to do this with a very large data set. Well, what then we can identify, is this a linear search or is this a binary search? And you should be able to identify that from the algorithm. We're going through every single piece of data and comparing. Well, we're looking for values over 300. So we're going through every one. We're not dividing and conquering. We're not doing a split. So it's a linear search. So we know that a linear search will work on an unsorted list. Okay. However, because it's an unsorted list, it's going to have to go through the entire data set to check that it was over 300. Whereas if it was sorted, then it would only need to check those values that were over 300, because it could discount the values beneath 300. So it could be a lot more efficient. So with this data, the data is unsorted, so the algorithm will have to search through every single item, to be sure that it has found all values over 300. Okay, we'll check the mark scheme in a minute, because essentially we've got one here, 308 is at the end. Okay, now with a 6 data set, it's not massive, it's not huge, but imagine that you've got, they've got 1,000 vans. It says, I think they had 2,000 employees right at the beginning. We don't know how many vans they've got, but if they have 1,000, it's going to have to go through every single one. Yeah. Whereas you could change it, so if it was in order, you would only have to search for the ones that were over 300. So let's have a quick look at the mark scheme, see what it actually says. Random order means that all items will have to be looked at to find all occurrences. Because the data is not sorted, the algorithm has to look at every item in the list to find all occurrences. So I think that's what I've written pretty much. So that was the inefficiency, that even though you don't have to sort a linear search, it's still more efficient if you do. Okay, if we think of the example where we look at students in the classroom, if you're searching for a student whose name begins with B and people are sitting randomly in the classroom, you start at one end, you might get lucky and you might find them first off. You might get unlucky and have to check every single student. Whereas if you arrange them alphabetically first, then you could alter your algorithm so that if I knew that they were sitting A to Z with A on the left of the room and Z on the right of the room, and I was looking for a student whose name began with T, I could start on the right of the room. I'd get there first, even with a linear search. So it would mean re-altering the algorithm a little bit, but that was what they were getting at there. So that's question 6, 6AI, linear search.